When a trained sniper pulls the trigger, the bullet follows a precalculated physical trajectory. There is no physical way to adjust the bullet's path mid-flight. The secretary bird hunts venomous snakes using the exact same lethal mathematical principle. Its devastating kick is a finalized brain command with zero chance for physical correction. Yet its accuracy on a moving, twisting snake is 100% perfect. How does a bird calculate complex spatial geometry faster than a serpent can strike? It uses a radical neurological shortcut. Welcome to the dusty plains of the vast African savanna, where survival requires biological weapons that bypass the limits of standard nervous systems. The secretary bird is an elegant predator with remarkably long legs. It earns its living by stomping heavily on the most dangerous reptiles on Earth. A snake on the ground is a small, unpredictable, and highly venomous moving target. If a predator uses standard reflexes to strike, the brain requires feedback time. You see the target move, your brain processes it, and you adjust your hand. This feedback loop takes a fraction of a critical second. But against a striking cobra, that tiny fraction guarantees a fatal venomous bite. The bird does not rely on feedback. Instead, it utilizes a bizarre mechanism known as feed-forward motor control. The bird's brain acts as an organic ballistic computer before launching an attack. It stares at the moving serpent and predicts precisely where the head will be. A single, unalterable electrical command is sent down to the muscular legs. Once the leg lifts off the dirt, the strike trajectory is permanently locked. The bird effectively attacks a point in space where the snake is not yet located, trusting that the reptile's head will slide perfectly into the deadly designated impact zone. It is a massive evolutionary gamble. If the calculation is wrong by a single millimeter, the bird will likely die. But these birds have spent millions of years perfecting their internal spatial geometry algorithms. This mathematical feat requires flawless visual data input. Unlike most birds, the secretary bird has large eyes facing directly forward. This creates overlapping fields of vision, providing perfect three-dimensional depth perception. It measures the distance to the hostile target down to the finest detail. As the bird approaches, it stomps its feet heavily on the dry grass. The intense vibrations act as a terrifying warning signal to hidden reptiles underground, forcing the frightened snakes to abandon their burrows and slither into the open. The bird immediately spots its prey and begins a specialized combat dance. It spreads its massive wings to confuse the snake and maintain physical balance. The snake coils and prepares to strike at the exposed lower legs. But those legs are covered in thick, impenetrable scales. The bird raises its leg high, creating immense mechanical leverage at the knee. The mathematical command is executed. The heavy foot drops like a specialized biological hammer forged by natural selection. It strikes with an astonishing force of 195 newtons. That is equivalent to 5 times the bird's own body weight focused into one point. The impact lands squarely on the back of the serpent's fragile neck. A sharp, dry crack echoes across the silent savanna. The snake's spinal cord is instantly severed, shutting down its deadly venom delivery system. The entire brutal execution takes less than 15 milliseconds to complete, which is literally 10 times faster than the blink of a human eye. The mathematical calculation was flawless. To handle such extreme impact forces, the bird requires specialized skeletal architecture. The lower leg bone, called the tarsometatarsus, is unusually dense and heavy. If the bone were hollow like a normal bird, the kick would shatter it. Evolution traded lightweight, flying efficiency for raw, bone-crushing physical durability on the ground. The bird spends most of its day walking tirelessly across its vast territory, covering up to 30 kilometers a day in search of new reptilian targets. Once the snake is dead, the bird does not tear the meat apart. It tosses the lifeless body into the air and swallows it whole. Consuming the venomous head first ensures the scales do not catch in its throat. Strong stomach acids dissolve the venom glands, neutralizing the deadly chemical threat safely. Despite its unusual, crane-like appearance, this creature is a true raptor. DNA analysis proves it is closely related to fierce eagles and hawks. It simply adapted its ancestral hunting skills for a life on the dusty ground. The ability to calculate precise trajectories without feedback is not unique to birds. Professional human athletes use similar feed-forward mechanisms to hit fast-moving baseballs. A batter cannot adjust a swing once the ball is halfway to the plate. They must predict the location and commit entirely to the muscular movement. The secretary bird plays this exact game of high-stakes biological baseball daily. But instead of striking out, a mistake results in a fatal venomous injection. The wild environment punishes poor mathematics with instant death. Only the most accurate biological computers survive to reproduce and pass on their genes. This ruthless selection process ensures the species remains an elite snake-killing machine. A perfect synthesis of advanced neurobiology and brutal physical biomechanics. The snake populations on the savanna are kept in check by these towering predators. Without them, the venomous reptiles would quickly overrun the fragile local ecosystem. They are vital regulators of the complex African food web. As the afternoon sun beats down on the dry yellow grass, the secretary bird continues its endless, rhythmic march across the vast plains. Its sharp eyes constantly scanning the ground for the slightest hostile movement. It is a majestic, elegant creature that commands respect from every ground-dwelling animal. Every step is deliberate, and every movement is calculated with pure mathematical precision. It is a living, breathing testament to the power of specialized evolutionary design. The next time you watch a predator strike in a nature documentary, look closely at the subtle, invisible calculations happening beneath the surface. Survival is rarely just a matter of having bigger teeth or sharper claws. Often, survival depends entirely on processing information faster than your deadly opponent. It is a war of nervous systems and predictive algorithms. A hidden battle of biological mathematics playing out in the dust. The secretary bird has mastered this deadly game of spatial prediction. It stands as a symbol of evolutionary brilliance and unforgiving natural precision. An avian sniper that never misses its target, walking the fine line between a successful hunt and a painful demise. This is the raw and undeniable truth of life in the wild, where physics and biology combine to create the ultimate survival strategies. The endless arms race pushes every species to their absolute physical limits. And the secretary bird responds with a devastating 15-millisecond kick. A kick that permanently ends the reign of the deadliest terrestrial serpents, securing its position as the undisputed mathematical genius of the savanna. A true marvel of the wild, untamed African landscape. Driven by instinct, perfected by time, and executed with lethal grace. The cycle of predator and prey continues its unbroken rhythm. An eternal dance of life and death beneath the equatorial sun. The savanna forgives nothing. And the avian sniper forgets nothing. A silent executioner roaming the plains, The magnificent secretary bird.